This may be my favorite lab that we do all semester because it's kind of like this cool little biophysics forensics experience. Okay, and so I'll warn you, it is a lot more detailed, and there's a lot more that you're going to be learning and picking up here than you will have learned last week. Okay, so for that reason, I'm going to try my best to be as clear as I possibly can and make sure there's as few questions after seeing this video as possible. Okay, but here's the scenario. Okay, you're going to be given a set of videos of cell motion. Some of those cell motions are going to be E. coli bacteria, and some of them are going to be neutrophils, which are basically white blood cells. Okay, and so obviously, white blood cells are designed to be able to kill bacteria, right? It's part of your immune system, okay? So the scenario is a patient has a wound, and in the process of healing, that wound has become infected with a bacteria. Will a patient need antibiotics? And by comparing the velocities of the neutrophil white blood cells and the bacterial motion, you can come to a decision about whether or not that person is going to need antibiotics. Okay. Now, as far as what you're going to turn in, at the end of the lab, not necessarily today, but just by Friday, you and your partner or you individually will submit a lab report including tables for 2 videos, right? Which are going to include the velocities of that you're getting from those videos. A calculation of the average velocity for both the neutrophils and E. coli. So by analyzing the video, you're going to get several velocities, and you're going to find the average. Basically, you want the average velocity of the E. coli and the average velocity of the neutrophils to just get a sense of how fast each are able to go. Okay, and then you're going to write a paragraph, a detailed paragraph, explaining whether the patient needs antibiotics and why, and that should also include an explicit comparison of the white blood cell and the E. coli velocities. Okay, you are going to upload this as one PDF report as you did last week. Okay, now before we can do an analysis of the videos, we need to know what these videos are, what the specifications of them are. So for example, wound healing we're not going to be using for actually solving the problem, but it is interesting because you can actually see over time the speed at which a wound starts healing. But the white blood cell neutrophils and the bacteria videos are much more important. Okay, so if our program, this Fiji program, is going to be able to calculate the distance between the white blood cells between 2 frames. Remember, frames are the little pictures that come together to form one whole video, right? So in adjacent frames, you can see in one change in frame how much the position will change or how much the white blood cell will move in that amount of time, right? But in order to analyze that, we need to know how many micrometers are equivalent to each pixel in the video, okay? Because then the program can convert to you, if let's say the white blood cell jumps a certain number of pixels, how many micrometers is that? Okay, and then if we know how many micrometers that is, we can divide by the time between the frames to find the velocity. Okay, and luckily the program does that for you. It's really cool. And so you also need to know that this video plays at 25 frames per second, right? From this, we can find out how many seconds there are per frame, right? It's going to be some fraction of a second. So you can take 1 second, divide by 25 frames, and you now have the time jump between each frame, okay? And so you're going to be inputting this information into Fiji, which I'll show you how to do in a moment, okay? And then you are going to use that to find the velocity, which I'll also show you. Notice in the specifications for E. coli, we flip and say it's 156 pixels per micrometer. Don't let that mess you up. You can still find out how many micrometers it is per pixel from that. It's just a little bit different so that you guys just get used to playing with units in different ways. And again, this one's going to be 25 frames per second. Okay? All right. So let's start by actually looking at the assignment. This is what you guys are going to see. You guys are going to see a link to download Fiji. Click this, and for whatever whether you have Windows or Mac, it'll give you options for downloading this program. Okay, it's super cool. It's super powerful. I totally recommend, finding other cool, microscope videos online and, doing some data analysis inside there if you feel like you want to play around. Here are the 3 videos that you will need: the E. coli video, the Nutrafile video, the wound healing video. Go ahead, download those, maybe put them on your desktop or make a little folder for them. And then you have the written instructions right here, which are these guys that I had open. Okay. Once you have Fiji open, this is what you should see. Actually, you shouldn't see that quite yet. I'm going to close out the videos that I already had. Okay. Bye-bye. Bye-bye. Too many. Okay. So I'm going to go to my applications, right? And I'm going to find, well, I'll just go ahead and do a search. I'm going to put searching Fiji. And there it is. I open it up. And I'm waiting for it. Oh, there you are, Fiji. Okay, cool. So I'm going to click Fiji. I want to click on this guy, right? And then I want to go to, first thing I want to do is I want to go to import, okay? I'm going to import an AVI. So all those files are in AVI files, okay? So once you've downloaded and installed, you go there. And now I have my videos for this lab, okay? And, let's just take Nutrafiles first. Okay, I'm going to look at the Nutrafiles. And just click OK here. And so you have this video, and I'm just going to play it really quick. And you can see all these guys are just moving along. And it's repeating, but these are all Nutrafile. These are white blood cells moving and a video taking a recording of it, which is really kind of cool. Okay? And so what I want you guys to do is pick one where the motion's kind of clear so that we can analyze the motion of that guy. Okay? I honestly like this guy. Let's take that guy. He's kind of just cruising through there, okay? So I'm going to focus on him. And again, as I focus on him, I want to focus on the same part of this guy every time, every frame. Okay, so we'll do the leading part of the white blood cell, and in the direction of the motion. So his front, given the direction of the motion. Okay, and so now I want the program to be able to analyze his motion for me, right? So I want to go over here to plugins, and I want to go to tracking. So we're going to be analyzing the tracking. We're going to be basically tracking a white blood cell. And you want to go to manual tracking because you're going to do this manually. So click manual tracking, okay? And then up comes this little guy, and you want to click show parameters. At first, sometimes parameters aren't shown, so click show parameters, and this is what you got here. The first thing it asks you to do is to find the time interval between frames, okay? It has 2 seconds as default, but it isn't 2 seconds, right? Really, this is 25 frames per second these videos are at, right? So I want to take 1 divided by 25, actually, okay? So I do 1 divided by 25, right? And I get 0.04 seconds. So each frame is 0.04 seconds, so I put that in there, okay? Now I also want this XY calibration. This is where you put the number of micrometers per pixel, okay? Now, if you go back to our guy, for the Nutrafile, the white blood cell videos, it's 1.326 micrometers per pixel, okay? So I go back to Fiji, and I say this is 1.326. Did I get that right? 1.326, yes, perfect. So I put that in there, right? Now, this means that the program knows that each frame, that each pixel is 1.326 micrometers big, right? And it can convert that to a distance. Cool. So now I hit add track, okay? And now I can begin tracking one of my guys. So we picked this guy, I believe, and I want to pick someplace more in the middle once his motion really starts to get going. So you can see him moving. That should be fine, right? So now I'm going to click the tippity tips of this guy right here. Boom. Okay? And now I have my first points in this motion over here. Okay, and it tells you that there's going to be a column for velocity over here and a column for the distance that it goes. So watch what happens. So I click, we're on the next frame, and now I'm marking his position there. Boom. Now he advances a little bit more. I mark his position there. Advance a little bit more. 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 It's very subtle, but you want to find the tip, the leading tip of this guy at any given point. And you're finding his velocity. So I'm going to keep doing it, and I'm going to keep doing it until I get a little bit of consistency. I get some numbers, so it's like kind of a stretch where he's moving at roughly the same velocity, okay? And yeah. So what? Yeah, there was this chunk here, where it was kind of consistent. Let's just keep going a little bit more. So you guys kind of get the idea. It's, the speed is roughly somewhere between 74 and 136, right? Is like a typical value that we're getting on this guy, right? There's some frames where the white blood cell may stop for a second, right? Those, they're not interesting because you're not actually finding his velocity, right? But you just want to get a ballpark image of what the speed of this guy is. And in this stretch here, your guys won't necessarily be the same. You won't necessarily pick the same white blood cell. In fact, I encourage you to pick a different one. There's many here to choose from. But you can kind of see this is kind of the range. Now, if I take these values here, right, and add them up, I'm going to say take at least 5 values. Add them up and divide by 5 to find the average, right? And so you want to find the average speed of this white blood cell, okay? And so if I add up 74 plus 74 plus 74 plus 119 plus 33, I'm just doing a ballpark off the top of my head here. Let's say that is, roughly 85 micrometers per second. So then we know that the average speed of a neutrophil is about 85 micrometers per second. Okay? Does that make sense? So you're going to want to make a table that shows 5 velocities that you got from your tracking analysis here, right? Show how you calculate the average, all right? That's going to be 85 micrometers per second, roughly, right? For at least it is for this guy. And then you're going to do the same exact thing for the E. coli. So now, so here, we'll go back to EGO here. So I'm going to go here. Actually, gotta do this. I'm going to do File, Import, AVI again. And this time I'm going to do the E. coli. Okay? And this video looks like this. If I play it, you're going to see these guys going. This is a little bit easier to find the motion of a guy because this guy, you can see right here that this guy's just shooting across the screen, right? Almost like a comet. This guy's just shooting. So it's very easy to find his velocity, okay? And so you want to add track again. I'm going to go to plugins. Plugins. And I'm going to go to tracking, manual tracking, right? And this time we have to set our new time and XY calibration. We go back over here and we see that for E. coli, now it's 156 pixels per micrometer. You want to convert this into micrometers per pixel and put that over here. Okay, find out how many micrometers per pixel, and then you're gonna go here again and see for bacteria, it's again 25 frames per second. So just like last time, it's going to be 0.04 seconds. Okay, you're going to add another track. Okay, and there's the head of one of these E. coli's, and he's moving again. He's moving again. This is a little bit easier to find, right? He's moving again, moving again. And now you can find an average velocity. It's this many micrometers per second for the bacteria, okay? Find an average velocity here, and you want to compare those velocities and then ask yourself this question: will this guy need antibiotics? Okay? And I don't want to give away the ending, and I want you guys to think about how you might possibly determine whether or not they might need antibiotics by comparing the velocities. But that's basically it. You then will, in your lab, draw, you'll include those data tables that show, several velocities, that include several velocities that you're then going to take an average of, so that you find the average, and then compare those velocities and write up a paragraph explaining whether or not this guy will need antibiotics. Okay? Yeah, that's it. If you have questions, reach out. But I do encourage you, before reaching out for questions, because I do get inundated with them, really kind of play around and think through stuff. And if you're truly stuck, when you feel truly stuck, feel free to reach out to me at that point. Okay? With that said, I wish you luck. I hope this is kind of fun and interesting to see these microscopic videos of white blood cells and bacteria. Remember, the white blood cells, bacteria is to find and destroy the E. coli. Right? All right. So without further ado, go ahead and enjoy this experiment.